Hey guys, I'm a verified educator at Unacademy, and along with that, I'm also teaching live at Unacademy Plus. To access my live classes, you can take Unacademy Plus subscription. Now, Unacademy Plus offers some interesting features apart from live classes, which include detailed and complete explanation of a particular course. Then there you have problem discussion for self-evaluation. You can also watch recorded version of the class in case if you miss out any live session. You have regular doubt clearing sessions for doubt clearing and to clarify all your problems. You also get access to the WhatsApp group to clear and discuss problem among the other plus students. Now, if you have found these features interesting and want to join Unacademy Plus, I'll recommend you to use my referral code that is N underscore Huda to get 10% discount on the subscription fee. Now that's all about Unacademy Plus. Let's continue with our video. Alright, so we'll discuss this question over here, and it was asked from your organic spectroscopy for 4 marks in CSIR June 2019 exam. And to solve this question, you need to know three things first of all. First is your IR spectroscopy, second is your NMR spectroscopy, and third is your mass spectrometry. So these three things you should have a thorough you should have a thorough knowledge of these particular three things, right? Now, all right. So it was a good question, first of all, I would say, and it was asked it was asked in a way that you have to tell that among these four options, how you can which option has the following spectral data. Now, this is one of the question which you will get in all CSI net exam. So let's start with it. I'll just tell you that how you can approach towards the correct answer, right? So you have four different options. The best way to approach towards the answer is to eliminate a particular option first of all, just by looking into the data. So whenever you will study the data, whenever you will look upon to the data, one or the other options will be cancelled out immediately. So let's start with it. So the IR spectrum is given over here, that is 1685. Now if you have knowledge of IR spectroscopy, you can easily predict that this 1685 is IR band or the IR stretching frequency observed for alpha beta unsaturated ketone. Okay, that means, or you can say that conjugated ketone, right? So a conjugated ketone shows peak carbonyl frequency at 1685. This is well and known value, and you should also remember this. I would say that if you have not studied IR spectroscopy yet, I'll just suggest you to memorize all the carbonyl frequency, basically, all the, like, for aldehyde, for ketone, for carboxylic acid, for ester, and then for acyl groups, for amide. So for all these groups, you should remember the carbonyl frequency. Also for your conjugated ketone. So for conjugated ketone, you get a value around 1685. Now once you know that, you can easily say that option A has a conjugated ketone. This is the conjugation with this ketone. Now option B has this conjugated ketone. Option C does not have a conjugated ketone. You can see over here, it is a like it's not in conjugation, right? So this particular group where you have carbonyl group and a chlorine group adjacent to that, it shows you an IR peak around 1725 centimeter inverse. Okay, so that's the value of 1750, around that, because you get peak over there in that particular region. So this is certainly not the region for that. So obviously you can cancel that out just on the basis of your IR peak, okay, or on the basis of the IR data. Fourth option is also like a conjugated ketone. So fine, you have now cancelled out one of the option. Now you are left out with A, B, and D. Now let's go into the NMR, right? So in NMR, okay, so in NMR you can see that where you are getting this N. Okay, so let me just tell you one thing. There, whenever you have a phenyl group or a benzene ring, that to substituted benzene ring, now you can see in option A, B, and D, you have three kinds of, like, basically two kinds of benzene rings. A and B have a benzene ring which are para substituted, right, or 1,4 substituted, whereas D option has a meta substituted or 1,3 substituted. Now how many types of signals you will get over here? So in this, like in A and B, you will have two kinds of proton. In the benzene, I'm just talking about the protons of the benzene ring. So this will be A, this will also be A, this will be B, and this will also be B. In option B also, if this is A, this will be A. If this is B, this will be B. So only two types of protons over here. But in option number D, how many types of protons you will get? So A, B, C and D. So four signals you should get in the aromatic region. But if you look upon to the data in the aromatic region, you just have two signals. That certainly tells you that your substitution is 1,4 substitution, not 1,3 substitution. So again, you can simply cancel out option number D. So just by looking into the data, you can easily cancel out option C and D. Okay, now you are left out with option A and B. Now if you go with the NMR data, it will be very difficult for you to predict, because there is just the difference in the electronegativity of these groups, that is bromine and chlorine. Just the position of those groups are like the position of the groups have been shifted, or they have been interchanging the options. So either you should be very precise with the values of chemical shift, you remember the values exactly, then only you can go with that, or the second way is to go with the third option, that is for the with the mass data. So these are your mass data provided to you. Now if you look upon to the mass data, what you can see is that you have a peak. First thing, you should go with the peak ratio. Okay, so the relative abundance, which shows the relative abundance of the isotopes. So you have a peak ratio of 1 is to 1. Fine. Now if you have a ratio of 1 is to 1, and if you have halogen in the compounds, you should know this thing, that if you have bromine in the molecule, you have intensity ratio of 1 is to 1. Okay, if you have chlorine in the molecule, then you have intensity ratio of 1 is to 3. Okay, so this thing you should remember. Okay, or like 3 is to 1 basically, not 1 is to 3, so it should be 3 is to 1. Okay, so now this is something which you remember and which you should know. Okay, now let's go to the options now, like how you can go, like both of them have chlorine and bromine both. But if you just look, both the options I have given just 1 is to 1 and 1 is to 1. That means it's not showing any trace of bromine. And if you look upon to the molecular, like if you just take about the molecular mass of whole molecule, it will be more than 200. So they are not giving the value. They have not given you the value of the whole molecule. Okay, they have given you about a fragment. Okay, so either this 200 or 198 or 185 or 183. These all are the values of the mass, like these are the mass values of different fragments. Now to go into the fragments, you have to deal with the McLafferty rearrangement over here. So that is one of the very important concept of your mass spectrometry, and you should know that. So let's go with it and let's try to see that how that will happen. So let's go with the option number 1. I'm just taking option number 1 just to show you. So let me just draw this first. Alright, so this is the, your option number A, which I have just drawn. Now if you look upon to the carbonyl compound, and if you just start numbering, like labeling the carbons, so this is alpha carbon, this is beta carbon, and this is gamma carbon. So gamma carbon has a hydrogen, right? That is called as gamma hydrogen. So if you have a carbonyl group and if you have a gamma hydrogen present to, like if you are on the gamma carbon, if you have hydrogen to that, there is a chance of having, like there is a chance of McLafferty rearrangement. So what happens in McLafferty rearrangement, that this oxygen will interact with this hydrogen, and this particular bond will shift basically on this side. This will shift on this side. Oxygen will have a radical. This bond will again like shift on this side, this on this side. So hydrogen radical and oxygen radical, they will combine to form OH bond. You will have a radical at this particular place, and this bond again will break. So bond between alpha and beta carbon breaks, and a radical will be formed here, which will form double bond over here. A radical will be formed here, and a radical will be formed here, which will form a vinyl chloride, right? So what you will get is two fragments. One fragment will have a structure something like this. Let me just draw this. So here we will be having OH and double bond over here. Here you have bromine, plus along with that you have like double bond and Cl. Okay, so you will be having something like this. So again, this is a fragment, so let me just show it like this. Okay, now if you just check the mass of this particular fragment, if you just look upon to the mass of this particular fragment, bromine has a mass of 79, and then you take these like C6H4 for this particular unit. You have like you have CH, like C2H2 over here in this unit, and OH. If you add all of them, you will get 198. Okay, if you take bromine as 79, and when you take bromine as 81, because bromine has two isotopes, 79 and 81, so when you take 81, you will get mass of 200. Okay, so 200 and 198 you will get over here, and also the relative abundance will be 1 is to 1. Why? Because you have bromine in this fragment. So that means this much thing has been sorted out, and that you got by option number 1. Now how you will get this particular option? This you will get when again the fragmentation will happen. Again this ketone tautomerization will take place and this fragmentation will be done. So the left out portion will have 185 and 183, and there also bromine will be there in the fragment. So that's why its relative abundance is given 1:1. So why they have not given why they have given 1:1? Just to show that in the major fragment you have bromine present. Okay, so that's why they have given you again and again that 1:1 is given to you. That is just telling you, so that is just telling you about that you have bromine in the major fragment. So that's how you can predict that option number A is your correct option. What about option number B? Why not option number B? So you can just check like whatever I have done for option number A, you can do the same thing for option number B also. Just keep chlorine over here. So that time you will see that you have chlorine has a mass of 35 and 37. Just put that value, you will get this particular value around around 40 units less. That means your value will come around 140 or 160 or something. Okay, and also the relative peaks will be like 3:1, because you will be having chlorine over here, right? So the peaks will not be 1:1, that will be 3:1. So since the data tells you that you should have bromine in the major fragment and the mass has also been satisfied over here, so that tells you that your option number A is the correct choice for this question, and that is going to be your correct answer. So this is how you approach a particular question from organic spectroscopy, where you have to deal with the IR to eliminate one of the option. Then we went for NMR to eliminate one more possible option, and then we went into the mass spectroscopy to find out when we have choice between the two options, we try to find out using this particular thing, right? Now you can justify all the other NMR peaks on this molecule, that I'm not going to do over here. I think that you guys are smart enough to do that. So let's go for the next question, because I just want to make this video very precise. So let's go to the next question. Alright, so we'll go for this question now. This was the second question from organic spectroscopy, which was asked in your CSIR June 2019 exam. And this was a very different question, and I don't think this kind of question has been asked yet in CSIR net exam in the previous few years. So it's very important to for all of you to understand how this question has to be done. Okay, so thus it says that the reaction of styrene is given to you when it reacts with HBr. It gives a mixture of regioisomers A and B. A will be major and B will be minor. So the proton NMR spectrum of the mixture shows four signal among at so you have four different values of the proton NMR signal given to you. The relative integration is also given to you. They are asking about the molar ratio of A and B. So this is very different kind of question. I would like to explain you this in a very precise way so that you all understand it well. So let me just first of all draw that what will be your styrene. Okay, so let's say this is our styrene. Alright, so this is our styrene, and when you are reacting it with HBr, when you are treating this particular thing with HBr, so there are two possibilities. There are two products which are possible. One which will be formed from more stable carbocation, so CH3, and here it will go. So bromine will go over here, and that will be your so this will be your Markovnikov product. That what you would say in the basic easy language, or you can say that the product formed from the most stable carbocation, right? So both are the same things actually. So CH2Br. So these are your two products which will be formed. So this particular one will be major. So this will be A and this will be B. That is, as it has been already told you in the question, that A has to be major and B has to be minor. So A and B. So that's how we got A and B. Now it's given that you have four signals over here. You are getting four signals. Let's say this is A signal because of this proton, this is B signal because of this proton, this is C, and this is D. That's what you are getting, these different A, B, C, and D. Okay, so let me just first of all give the values of these A, B, and A, B, C, and D based upon the based upon this particular data. Okay, so if you don't know the data, then also you can go for that. But it will be better that if you can just relate the values. Okay, so if you have watched my previous videos on how to predict NMR spectrum of a given molecule, or how to understand that a particular structure will correspond to the particular value. So over there I have explained that the proton which is attached to more electronegative group goes downfield. That means its chemical shift value will be high. So if you look upon A, B, C and D, so A is attached to bromine and also electron withdrawing group, that is your phenyl ring. So that means A should have the highest proton, it should have the highest chemical shift value. Now one more thing, just before going into that, you might be wondering that why I'm not taking any proton of this phenyl ring, because there is no value given over here in the aromatic region, right? So all these values does not lie in the aromatic region. So that's why you can say that, okay, the aromatic protons have not been considered over here in this question. Okay, now going into that, so by that what you can say that A has a chemical shift value. Let me just write down over here. So A has a chemical shift value of 5.17 ppm. Then if you look upon to B, C and D, so now which among B, C and D which is attached to other electronegative group. Now the next electronegative group, that is bromine, and this is D. Okay, so D is also attached to bromine and C is attached to phenyl ring. Both of these groups are electron withdrawing groups. So both of these values will be will have little higher value but less than this A. So if you have to choose between C and D, whose value will be higher? So obviously bromine has more electronegativity. So this D proton D will have the next highest value. So D will have the value of 3.53. Now coming back to the C, so C will be nothing but your 3.15, and B will have the least value because it is not attached to any electronegative group directly. So it will have a value of 2.00. Now these are the different chemical shift values. That means the order, if I write down the order of the of these particular groups, so it is like A is most, then D, then C, and then B. So why I have done this, why I have arranged them in this order, because this integration peak has been given in that order only. Okay, so that integration peak is always given in the order of this because it has been given that the relative integration is this respectively. That means it correspond to these values. So this is better to like arrange them before going into the next part. Now what about this, how to understand from this relative intensity that what will be the molar ratio? So before going into that, I'll just give you example. Okay, just try to understand with the help of example for those who are new to this concept. Okay, let's take an example. Let me just take a molecule, that is CH3CN. Okay, this is one of the molecule, and let me just take another molecule which is mixed with it. Let's say I have taken okay, so let me take CH2 CH3 Cl. Okay, so these are the two groups which I have taken. So this particular okay, so if I write down the intensity, okay, so if I take both of them as 1 mole, like the molar ratio, if I just take 1 mole of this and 1 mole of this, then what will be the intensity of these peaks? So you will get a peak because of these 3 hydrogen, you will get a peak because of these 2 hydrogen. Sorry, this should be 3 and this should be 2, right? Sorry, yeah. So these should be like, these are the 3 peaks which you will get. So the intensity of the peak or the height of the peak depends upon the number of protons which are attached to that. Okay, so since both of them are 1 mole, so that's why it has 3 hydrogens. So it will have a peak height of 3 units. Then if I talk about this, so it will have a height of 3, and then it will be 2. Okay, so if I write on the ratio, if I write on the ratio for this mixture, it will be like 3 is to 3 is to 2. So 3 correspond to this, 3 correspond to this, and 2 correspond to this. So this is when I have taken 1 mole ratio of both of them. Now let's say that instead of taking 1 mole, I am going to like make it as 2 mole. Okay, so let me just do that. Yeah, so this is CH3 and this is CH2. Let me just take it as 2 mole and this as 1 mole only. So what will happen now? Since I have taken 2 mole, so now the number of protons over here will be twice as the number of protons over here. So instead of writing it as 3, it will be 3 into 2. The number of moles it has, you just have to multiply to get the intensity height. Okay, so that's how you will get. So 3 into 2 will be 6. So the height of this peak will be 6 times. Okay, now about this, so it will be like 3 times and this will be 2 times only. So if I write down the peak ratio, so it will be like 6 is to 3 is to 2. 6 will correspond to this, 3 will correspond to this, and 2 will correspond to this. Why it happened? Because I have increased the molarity of this. So the molar ratio have changed, then the peak or the intensity of the peak will also change. Okay, so by changing the molar ratio, you will get different intensity of the peak. I can just divide this whole with 2 to get the simplified the answer in the simplified ratio. So it will be like 3 is to sorry, I cannot divide, right? 3 and 2, like all of them cannot be divided, so all of them cannot be cancelled out with a single number. So yeah, I cannot cancel them. So it will be 6 is to 3 is to 2. So that's when I have changed the molar ratio. Now I can do one more thing just at the last time, just to make you understand once again in little bit detail. Let me just take it as 1 mole only, and let me just make it 3 mole. Okay, now what will happen? So these 3 protons will remain 3. The ratio will be 3 only. For this, it will be 3 into 3, that will be like 9, and this will be like 3 into 2, so 6. So here the new ratio will correspond to 3 is to 9 into 6. This 3 correspond to this particular 3 hydrogens, 9 correspond to this 3 mole of this CH3, and 6 correspond to 3 mole of this CH2. Understood? So what is it? That the intensity of this peak also depends upon, like it depends upon the number of hydrogen, also on the molar ratio, that how much moles you are taking for that particular molecule. So now you can simplify this, you can make it like 1 is to 3 is to 2. So this will be your simplified answer. Fine. So this was just exercise, just to make you understand that what is actually happening. Now let me just take this particular, for this particular case, let's just take it and just try to understand it. Okay. All right, so initially let's consider that the right, so initially let's consider that the molar ratio is 1 is to 1. I am taking 1 mole of this, let's say, and 1 mole of this. I have not I have not changed the molar ratio. These moles are 1 is to 1 only. So what will be the intensity which I will get? So I'll write down the intensity in this order only: A, D, C, and B. So A, how many types of A is there? So A is 1, like A proton we have 1 type. D, how many types of D protons are there? So 2 D protons. Then what about C? So C protons are also 2, so 2. And what about B proton? So B proton is 3. So this is the value which you will get if the intensity ratio is 1 is to 1. But in the options we don't have 1 is to 1, right? So what you can do now, you can just go into the options one by one, put the values, and then solve, and then see that which option satisfies the given ratio. Okay, so let me just go to the options now. I'll take the first option first of all, that is 3 is to 2. So that means I'll make this 3 mole and I'll make this 2 mole. Now when I make this 3 mole and 2 mole, so 3 means, if I talk about A proton, I have to write down A, right? So I have to, A is one type of proton I have for A. I have to multiply it 3 times. So 3 into 1 becomes 3. Okay. Now the next ratio is for D. So for D we have 2 moles, and we already had 2 types of proton for D. So 2 into 2 will give you 4. Okay. The next is for C. So C is also 2 times, like 2 protons, 2 moles of that. So 2 into 2 again will give you 4, right? And then B, so B were 3 protons and 3 into 3 moles, like 3 moles we are taking. So 3 into 3 gives you 9. So this is what you will get if you take option number A. Is it the option, like is it the value which is given? No. So option A is wrong. Okay, we cannot go with option number A. Now let's change the values. Let's go for the option number B now. Okay, when you go for option number B, that means I'm taking 4 mole of this A and 1 mole of option number B, like of the product B. Now once I do that, let me just again take the ratio. So for A, well, we have to start from A. So A is one type of proton, 1 into 4, that will give you 4, right? Now the next one, D. Okay, so D, we already had 2 types of proton over here. So 2 into 1 will give you 2. All right. Now next is C. So C is 2 types of proton, 2 into 1 is 2. All right. Now the last one is B, right? So B is 3 types of proton, 3 into 4 is 12. So here I got 4 is to 2 is to 2 is to 12. Now can I cancel out with a digit, with a smaller number, to make it more simpler ratio? So yeah, I can divide this whole thing with 2. When I divide it, I'll get 2 is to 1 is to 1 is to 6, right? If I divide this with 2. Is it the value which is given in the question? Yes, this is the value given in the question. That means what? This is the molar ratio of the product A and B, which correspond to the intensity ratio of 2 is to 1 is to 1 is to 6 for these protons, for the protons having these chemical shift in the one major and minor product. So this is how you have to approach this question. Once again, let me just summarize it. First of all, you have to make the reaction. You have to see the major and the minor products. Then you have to just assign the intensity ratios according to the 1 mole and 1 mole thing, just to make sure, just for the practice of yours. Then the next thing is to assign, sorry, like before assigning the ratios, just align them according to the chemical shift values given to you. So the chemical shift values are given to you, just make a alignment according to that. So once you made the alignment, now like write down the intensity ratios of them. Now go with the options one by one. Make the molar values of that. Multiply the number of protons with the molar values to get the intensity ratio. Okay. So it was 1. 1 into 3 got 3. Then D was 2. 2 into 2 got 4. Then C was 2. 2 into 2 got 4. Then 3. 3 into 3 got 9. So that's how. So you have to multiply the type of proton with the molar value, and that's how you will get intensity peak. Okay. Once you have done that, you will get, just match the option which where you will get the given values. That will be your answer. So this kind of question was not given yet on CSIR net. It was a very good question, and I saw many students struggling with it, although it was very simple. Once you know the concept and once you know how to solve it, it becomes very easy to approach this kind of questions, right? So I hope this video was helpful for you. It was quite long video because there were many things to explain in this, and I hope this was a helpful video for you. And that's all for this video, guys. Thank you so much for watching. Have a great day. Bye bye.